If you have any questions, you can ask. But please participate in the class. Okay? Well, as far as the solid sphere is concerned, I think we should be able to do it. Solid sphere, solid sphere. Now, with there is an answer given there, but you should be able to do it. Will you do it for a solid sphere, all of you?
Will do, sir.
Fast, do it. I will also do it. For solid sphere. Good. You must take the challenges. Life is full of challenges. Right? Solid sphere of radius r, mass m. Okay? So, here we will have to calculate again, the sphere, and this is the axis, and we will again go for those of you who are very confident to do it, please do it on your own. Those of you who are not confident, then you follow me. Then you see, those of you who are very confident, you do it. Others, follow what I am doing. So, if I take this small dm here, again, from this point it is going to be smaller, and this will be r, and again if I take theta, this will be r sin theta. I can go by this method also, or one more method is, I will take the sphere. I felt that this is much more easier. I will take a concentric spherical shell. Concentric spherical shell of radius r, and this is dr. I think this is okay. So the dm of this will be equal to m divided by 4 by 3 pi r cube into this incremental space will be 4 pi r square into dr.
Yes, sir.
Good? Yes, good.
That would be.
So this will cancel, and r cubes will not get cancelled here. We will go up here. So our integration of dm into, again here, r sin theta. Okay? R sin theta.
Okay. Yes.
Got it? Again.
Sir, but dm for that you have taken. So okay.
Yes, sir.
Sir, for which?
Yes, you are right. So here you see the axis is going into the border, out of the border.
Anyhow, it is.
So that is it. You are right. You are perfectly right. Thank you, friend. So this will still be r. Correct?
Sir, no, sir.
How the bar order?
Sir, we have to take formulas like 2 by 3 dm mass.
Yes, sir.
We'll write it. Wait, I am just writing dm. I'll have to I have to write the values of dm. Okay, I am not.
No, sir, but since we are taking the sphere, so we should take 2 by 3 dm mass for integration.
We are taking the moment of inertia of that small sphere which are considered.
Yes, sir. So integration of 2 by 3 dm.
Yes, sir. Correct.
Integration of 2 by 3
into
dm mass.
Why 2 by 3?
That's the cross section of the circle. No, it's a sphere, sir.
It's all a sphere.
Which element of considered is a sphere, sir.
Yes, sir.
All a sphere.
Wait, I have not written the value of this.
Consider that single concentric shell.
This value dm will be 3m. Okay, 3m by r cube into r square.
Yes, sir. This is correct.
This is what I have to say.
Sir, what you are saying is that we should integrate the moment of inertia of the elemental velocity.
Yes, sir. So it should be 2 by 3 dm mass. The previous formula, sir.
We are integrating the moment of inertia, sir.
Of each sphere, sir.
I think we can directly take the moment of inertia of each hollow sphere. So that will be 2 by 3.
Sir, we have to take.
Yes, sir.
Okay. That's what you are taking.
Yes, sir, that will be correct. Yes, sir.
Got it. So I was about to go to that, the basic formula I am writing here. The basic formula I am writing here.
Okay, sir. Yes, sir.
I am writing the basic formula here. Got it? See, what I am assuming is there is a sphere. See, the sphere is in front of me, and the axis of rotation of this sphere is now, see, this is a sphere. I have taken this element, this one sphere here, and I am going through the axis here. Okay, going through this axis here. I was writing. Anyways, correct. What you saying is right. So we will use that formula, right? For this sphere, we will have to use the. You are telling you will use the previous formula and do it.
Yes, sir. 2 by 3 dm r square of integration.
Okay, now assume that we had not derived the previous formula. Assume that we had not derived this previous formula.
So then why we are taking as a constant in that the sphere as the elements? So
Then how will you go about doing it? If you have not taken the, if you have not solved the previous one without using that result, if you want to do it, how will you go about doing it?
So what I told you, the first you have done that figure first that way.
Sir, but this way it will do, sir. The
Yes, sir, it will be
is
easy.
only changing now, sir, for each of the shells, sir.
No, my question is, supposing we had not solved it for hollow sphere, then how we would have gone about doing it?
So then first for one hollow sphere we would have found out, sir, then we would have integrated that.
Yes.
You would have still gone by the same method.
Yes, sir, otherwise we cannot do.
Otherwise, you cannot do. Sure.
So give us some time.
No, wait. Aram se. हाँ, take some time. Take some time.
Yes.
Do it. You give me the incremental this one. Okay. Just see if what I have written makes sense. Hello. I want your attention, friends. 1 minute. Hello.
Yes. Yes, sir.
Now you imagine you are sitting at the, say you are inside the sphere, and r d theta, as we did last time. From the center of the sphere, I am drawing this line, r d theta. Clear?
Okay, sir.
Then r sin theta d phi, as we did last time.
Yes, sir.
Okay. So r sin theta d phi is the azimuthal line, and r d theta is this line. Now I have to go like this. Correct? So like this, if I go the thickness, I will take it as dr. So I multiply by dr. Then I will get the incremental volume.
Yes. Okay.
Okay. Now if I multiply this by m by 4 by 3 pi r cube into this volume.
Yes, sir.
This will give me what? This will give me dm.
DM.
Yes, sir.
Clear?
Yes, sir. Clear, sir.
Okay. So now my integration will be dm into r square. Now r square will become what? R sin theta whole square. Because with respect to this axis, again, that's incremental volume will be r sin theta. Clear?
Sir, here you are considering that dr thickness also, no, sir?
I am considering the thickness.
Yes, sir. Then how you can take this r sin theta as the radius perpendicular
Hey,
distance?
see again that see again you forget this. Forget this. You look at this diagram. See this element here. See this element here I am seeing, and this element I am seeing here. This
sir, yes, sir.
this element I am seeing. Not don't refer to the diagram. This diagram.
Okay, sir.
Okay, got it? See,
Yes, sir.
this one is dr. Like
Yes,
this,
sir.
it is dr. Okay. So I will have to write this, and it's going to be fun doing this, right? So I will write here into r square sin theta. This also I will write, and the limits of integration now is going to be 3 limits of integration. Why? Because we have a d theta, you have a d phi, and you have a dr. Hello?
So why after something?
Yes, sir.
See, now this is a sphere. I am looking at the small incremental volume here. From the center, it is at distance small r. Okay, and this is the axis. And where is this from this axis? If this is r and if this theta, this distance will be r sin theta.
R sin theta, yes, sir.
Clear? Now here you see
R sin
r square sin theta. Sorry. So here the limits of integration for theta will again be same 0 to pi. The limits of phi will be same 0 to 2 pi, and the limits of r will be 0 to capital R.
Yes, sir. Yes.
Clear?
Yes, sir.
So that's how the things will get majestically. I hope you got this, students, all of you.
Yes, sir. Yes.
Right? What I have done is I made use of spherical coordinate system.
Sir, one doubt. Sir, this dr is here, sir, that perpendicular distance which I have taken for the element, sir. If you take it from 0 to r, sir, like how will we know that it will be like that steradian I will take, like one thing which is taken out?
See, Arun, just see. Just imagine.
Can we,
Arun, just see here. This startup of mine, okay. Well, from this, if you assume that I am standing within the sphere, so I am looking at this element here. This element here. You see my finger
Yes,
here,
sir.
this element. So this thickness is dr.
yes, sir.
Okay, and my thumb. This thumb is what? This thumb is what?
Sir,
R. You can't see, right? Now you can see my thumb.
yes, sir. Okay.
So this distance now is dr.
Yes,
Okay,
sir.
and my thumb is indicating what? R sin theta d phi
R sin theta d phi.
is my thumb,
Okay. Yes, sir.
and my finger and my thumb is dr.
Yes, sir.
And this becomes what? This one is what? R d theta. R
Yes,
d
sir.
theta into R sin theta d phi into dr thickness.
Sir, yes, sir. Now this dr, sir, like from that point till the center it is taken, sir. So, like, how do you know that always dr, like, from any point on that element it will be from center only, like that, how can we tell, sir? So, it can be in the form of a cylinder type also or cuboid type also.
Okay, fine. Now you see, it's better that I teach you the cylindrical coordinate system and I teach this. Okay, sorry, spherical and teach this, because now I know I will end up doing that only. So let's consolidate, because 31st I need to cover the syllabus. So let me not go into this. Okay, we'll do by your control. But this is the way you have got to integrate that limit. So we will do it the way we have done this. So
Integration 2 by 3D.
yeah, correct. You will get it like that.
Yes, sir.
Anyway, there is a ready-made thing, you follow it. I was trying to get it with spherical coordinate system. Anyway, I'll end up doing that. I'll teach you that sometime later. We'll do it. So for a solid sphere, we have used already 2 by 3 df shell r square. So same thing, what you said here, r square is put here. So it's so, and we're substituting this, we get 2 by 5 mr square. Fine?
Yes.
No issues, right?
No, sir. Yes,
Right,
no.
fine, done. So we can do it by many methods, okay? So I was trying to use the spherical, but anyway, I need to teach you that. Otherwise, we'll end up with that. Fine, friends.
Sir, we'll get 2 by 5 marks.
You will get it. You will get it.
Yes, sir.
You will get it. Good. I am very happy. See, be very sportive, be very competitive, okay? Because your process must be, always towards, thinking. You think, you analyze, you get the answer. That is knowledge. And that is how you will develop skills. Okay, analytical skills, your attitude, everything will develop there. Okay, fine. So it's in a nutshell here. So now you can compare. This is 2 by 5 mr square, and that was 2 by 3 mr square. But you see, again I told you, this r is for sphere, solid sphere. That r is for the hollow sphere. Don't say that this r and that r are equal and this m and that m. One of them can be equal, not both of them. Okay. So this is it. Ml square by 12, the thin rod through center of mass, ring, cylinder. See, disc or cylinder, the formula will be same. Can you appreciate this?
Yes, sir.
Okay. So how will you justify for a disc and a cylinder? The formulation is same.
Right to the axis.
Yeah. So the thing is like this. So the thing is like this. So if you take a disc, then the axis is passing through this. So the moment of inertia of the disc will be mr square by 2. Okay. Now, as far as the cylinder is concerned, the cylinder is like this. But this you can split it into many discs. Okay, and it is about the center of axis. Okay, axis of rotation. Understood now? Hello.
Yes, sir. Yes.
So therefore, you see the way the mass is distributed about this axis is having same pattern. That is, about this portion of the axis, you will see the same way the mass is distributed. About this portion also same way. About this portion also same way. About this portion, it is all the same. But you must now be very clear that you see, when we write the formulation for this and this is same. Again, don't make the mistake. See, this cylinder is having mass m dash. Radius can be seen. Hello?
Yes, sir.
But remember this m dash. Okay? Or in other words, supposing the cylinder consists of, say, n number of this. Then this cylinder is having mass m dash. So now here this m will be equal to m dash divided by n. Remember, that is, it's sliced into this and you get it. Because it's all about, how the mass is distributed about the axis of rotation. Okay?
Yes.
Right.
Sir, one doubt there.
Go.
Sir, there is centroidal axis, I didn't get that.
Centroidal means passing through the center of mass.
Sir, but it's perpendicular, like in which direction, sir?
They are written, see, it is passing through the center of mass and perpendicular to the plane. A thin ring, man.
Sir, not that one, sir. Solid cone.
Solid cone.
About its centroidal axis.
No, solid. See, you know how a solid cone is?
Yes, sir.
So here you see, this is the centroid of the cone.
Oh, yes, sir. Yes, sir.
So the axis is passing through this.
Okay, like this. Okay,
Okay. Centroidal means it is passing through the center. Okay?
Okay.
Right, yeah. Of course, they should have written perpendicular to the base. They have not written. Okay? Right. Anyway, when we have time, we'll derive for all. Right?
Yes, sir.
We have time. Now, there is some more things. So, uniform thin rod bent into the shape of an arc of mass m. Okay, passing through the center and perpendicular to the plane containing the arc, it will be again IC will be mr square.
Yes, sir.
Okay, you can write it down and you can derive it and see for yourself, right?
Yes, sir.
You can take this theta and you can do it, right? So uniform ring of mass M, mr square. This we have done. So about this ml square by 12 we have done. Uniform disk mr square by 2. You can see this, and for the disk it is same.
Yes, sir.
Cylinder mr square by 2. Then diameter to the center homogeneous sphere of mass m 2 by 3 mr square. Okay. Diameter to the center 2 by 3 mr square. 2 by 5 mr square. 2 by 3.
Yes, sir.
Got it?
Yes, sir.